Lady Ada, what is this?
Hey everybody, and welcome to Show and Tell. It's me, Lady Ada. We're here, we're Adafruit, with me, Mr. Lady Ada. The Adafruit factory behind us. This is where we do all our manufacturing and testing and shipping and coding and kitting, electronic goodies that you love to make stuff with. And we've got a bunch of people from the Adafruit community and more. Come on by. We're going to be here for another 30 minutes or so. You can show off your project with the rest of the world. Wouldn't that be great? And we won't even grade you or vote you off the island. Everybody wins. So starting off with Shawn.
Shawn, I think, is standing in for Kevin this week.
Is it true?
Digi-Key.
I am.
Shawn, what you got going on this week?
All right. So as per normal demo day, my thing is not working, but
Yes.
I am happy to show what I have made.
Oh, what is that?
This is an RP2040. You probably can't see the little Raspberry Pi logo on it.
Okay.
And I made it to be kind of like a Pico. Yay!
It's Pico compatible.
Exactly. So it's Pico compatible. It's a Pico that's Pico compatible. And so the idea is that I would stack a Pico on it with these, Arduino style through headers, these long headers. And then I attach my I attach my what is this? The SWD port to the back, like so. Yeah. And it's a debugger shoe. So the idea is I've got the little things printed on the side here that are the numbers for the individual pins. And then the Pico boot is running on my RP2040 on the bottom one. And then so this just sits nicely in a breadboard, and it ideally gives me step-through debugging without having to do like the second breadboard with all the wires and whatnot. I just thought it was a silly thing I could make with the RP2040 to show off. And I learned a whole bunch of things about laying out the RP2040, namely QFNs stink to solder by hand. I was able to do it in the oven that's like right here. All sorts of bridged connections, came by with the hot air, tried to refix it. So I learned how to do QFNs, which was fun.
And they're 0.4 millimeter too. They're tough. Yeah,
they're not easy. That was fun reworking those. Got that to work so I could boot into it. I also learned that if you're going to be doing layout, if you're going to be doing your own RP2040 board, you probably want to stick with WinBond QSpy memory chips, because I tried a non-WinBond one and that straight didn't work. It didn't execute in place, I think is the term.
Yeah.
So I tried non-WinBond. So definitely order WinBond, or you have to like write a custom header file for your RP2040, like recompile everything if you're doing like Pico boot and then load that. That was like a future project.
Tried the generic 03, but yeah, this is like the first thing Scott and I, like when we were doing RP2040, we're like, oh, this is going to be really confusing for people, because it's rare that you would program a microcontroller and it doesn't start. Like, no, here's a new thing that you have to deal with when you're doing micro development on top of everything else.
All right, quick question, Shawn. So you called this a shoe or a boot? Because this is, there's shields, there's hats, there's fats, there's wings.
This goes on the bottom, though.
So it goes on the bottom. So are we calling it? Is it a shoe?
Shoe.
I called it shoe.
Shoe. Okay. So what if it went on top, though? What if it went on top of the Pico? Do you have a what do we refer?
It's a Raspberry Beret.
I like Beret. Beret's good. The hats were just for the big pie, though.
Yeah,
that's what I thought.
This is the thing.
And I didn't want to. Sorry.
No, naming sorry. So this is a shoe, not a boot. It's a shoe.
The reason I didn't go with boot is because if you type in Raspberry Pi or Raspberry like Pico boot, that is something that's a different thing on the internet.
Yeah. No, you had other choices. You had slippers,
sandals.
Yeah, flip flops. That gotta stay away from that. But that's good to hear. We can refer to this chat as one of the first times folks were calling what the thing goes underneath. Right now, it's a shoe.
I'm calling it a shoe. It's a shoe.
Because eventually someone will ask, will be like, why is it called this? It's like, well, here's a URL. Time-coded URL on Show and Tell. All right, got anything else, Shawn?
The only other thing, the reason it wasn't working is I'm running into USB issues. So if anybody has any pointers, please let me know in the chat, or if you want to go to the video, it's Digi-Key's YouTube channel where I talk about how I made it. It's a longer video. I went into like all the design decisions and whatnot. USB is just straight not working. Sometimes it works on a good day when it's not cloudy outside. Like it enumerates on my computer, and then today it's just like, no, device descriptor failed. I'm like,
well, make sure nothing's connected to pin 15, because that's used for USB.
Pin 15? Yeah, I don't think so. It's everything. Okay. Nothing should be connected except for like the SWD and UART pass-through.
Well, just check it, and then make sure you don't have another RP2040 already plugged in, because you can't have two plugged in at the same time. And then
looking at my desk.
Yeah, which might not work. And then second, check your crystal oscillators and your resistors, your inline resistors. Should be 22 ohms.
Yeah, that sounds right. I'll have to I can probe them again and check them. But I got it to work a couple of times for the video, and now it's just not working tonight. It's cloudy outside. So no, that's good. I'll go through that list and check them. So thank you.
All right, good luck.
And
thank you.
I'm looking forward to when you work on the next shoe, because then you can say, oh, the next shoe just dropped.
Oh.
I gotta get under. Okay.
Bye.
All right.
The hook comes right by.
Scott, what you got going on?
Okay, Scott.
Hello, can you hear me?
Hello. Yes.
So I don't do a lot of JavaScript and HTML, but WebBluetooth, now that I've got file transfer stuff checked into CircuitPython, it's now a question of like, how do we actually get files over there? So we know WebBluetooth is interesting just because Chrome has it and is everywhere. In particular, Chromebooks and Android as well has WebBluetooth support, I think. So I've been playing around with WebBluetooth. This is my proof of concept demo. So what I've got here is I've actually got, wrong camera. I'm using my cat cam. I've got this clue here. It's running CircuitPython, super latest on the code that's not even checked in, but it's battery powered, so it's not even connected to USB. But on my test page here, I can say request Bluetooth device, and it doesn't show anything. So I'll hit cancel, and I know you can't see that. But then after that, I can hit this connect to Bluetooth devices. So now it's connected. It's discovered everything. And if I hit this bond button, what it does is it connects up to all the file transfer stuff, and then it actually loads code.py. So this is the code.py as off of the device itself. I'm not sure why there's nulls here.
No.
So I'm going to have to figure that out.
Little mini nulls.
But what I can do is if I type like print, it's starting to try to write the files back to the device. I just haven't debugged it, why it's not working yet. So
this is cool. I like, I know that if you can get the workflow to be as smooth as USB, it could be so fun to have a wireless Bluetooth CircuitPython or Wi-Fi device, and you're like typing code to it, and as you save the file, it instantly uploads and it runs it. I mean, like that is that's what I love so much about CircuitPython. It's so fast to develop.
Right.
And
so what I have
now you don't have to do USB stuff. Like Shawn, his problem is solved. USB cable, who cares? You don't need it.
Yep. Exactly. Although the RP2040 doesn't have BLE. But the way that I have this working is that every time you change the text, it waits like half a second or 750 milliseconds, just like CircuitPython would, and then gathers all those changes and sends those off to the device. So it should feel relatively similar and hopefully just as good.
All right. Only thing that's missing is image magic. Somehow got to get that involved.
Well, I want to do the serial REPL stuff too, so I'm going to get some serialing stuff coming out as well.
Okay.
And Scott, you're doing a deep dive this week?
Yes, I'm taking days off next week, so I will be around on Friday.
Okay, everyone tune into Scott's deep dive. You're going to be showing this off? Maybe?
Yeah.
Okay.
Yeah, hopefully it'll be working.
If you want more Scott, Friday, deep dive.
Yep, 2 p.m. Pacific.
All right. Bye,
No.
buddy.
Like that.
Okay.
Your little friend. No friend.
All right. Now, Pedro, what you got going on this week?
Hey, what's up, folks? So this week we got inspired by the fun little keycap here. We thought it'd be a cool idea to see if we can make this into a keypad and just like instead of a single key. So here it is. It's not many keys, right? We have 4 keys, but we thought it'd be fun to make it into a kitty paw shape. And Lamar, you said, yeah, you can build that under what condition if you get Liz to do the party parrot. So we set it up as kind of 2 things. It can be a USB keypad, but it can also do MIDI, and you can just really easily change it in the code. So I thought it'd be fun to kind of do a little dancing parrot, right?
Yeah.
My hands are covering it, but you get the idea.
I think
Right?
that's
Really
cool.
fun display, and it's running off of the QT2040, which was running the RP2040, and it uses just about all the pins because it's a SPI connection, so there's like 8 wires for it, but it works really well for it. So if folks want to make a cute, maybe the cutest keypad, I might be a little biased on that, but
It's
you can
pretty
build one. And it's all 3D printed. We got snap fit parts that all snap fit together. And
Okay.
the learn guide went up,
Type 2 of the characters so the party parrot goes back and forth.
what's that?
Just type on 2 of them so it goes back and forth. Yeah. Now we're talking.
We gotta
right.
do the boots and pants. It's super fun.
Success.
Check it out. I learned a lot actually on the SnapFit stuff, so I'll probably do a little bit later on this one. But you can check out the Learn Guide. It's up there
All
right now.
right. Boss lady approved.
Okay. And then on your speed up this week on Ask an Engineer.
Excellent. Pokeball.
Yep.
Nice dragons on your shirt.
Thank you.
Yes, apparently they're from Sleeping Beauty.
Is there?
If you're
If you knew.
if you have someone on staff who's a dragon expert, which we do.
If you do.
Okay.
All right.
All right,
Bye,
so
folks.
Let's
Pedro.
go to Jeff, what you got going on?
Oh, I love you guys. You're the greatest. So I've been working for the last couple weeks on cameras. It all started with the OV7670 on the Grand Central, but we've now brought it onto 2 other platforms. We can do the RP2040. I don't recommend assembling it like this, but you can if you need to. And the newest edition is on the ESP32S2. This is actually live running a test pattern. ESP32S2, including this board with a dev kit called Caluga, which we chose because it has the camera connector built right in. And if you were watching closely, you would see that there were kind of 2 different styles of camera. We originally supported the OV7670, but we've added support for the OV2640, which is just a little nicer, a little newer, more pixels. So it's been fun adding support for these parallel capture peripherals and a little less fun debugging the initialization code for these, but it seems to be working pretty good. We've got a guide on the Learn system, and as always, we'd love to see what you do with when you hook up these cameras to CircuitPython.
I'm also looking, I like that you did a really good job abstracting away the camera init from the camera code, because it means that there's only new cameras coming out.
Right.
You know, a lot of code is like so hard coded to like this, it has to run the H1M11. And it's like, no, you can run, any number.
There's new cameras and new ink displays coming out by the hour.
Every day, I know.
So just okay.
To support another camera, there's all that you have to write is a CircuitPython library, in Python to do the I2C configuration. And then the image capture part that does the low-level I/O is the same on every camera we've done so far, which is 2. So there'll be a gotcha there, but we'll handle that when we get to it.
Okay, I'm excited. We want to do more image stuff and AI stuff. And I know this is like, it's the one step on a huge mountain.
This is one step.
It's one step, but it's also in a sense one of the harder steps because it's so platform dependent. The rest of it's going to be software. So hopefully not as bad.
One of our long-term goals is to make the easiest and a low-cost digital camera that you build yourself. So imagine that. You build your own camera and it's CircuitPython powered. So that is it's one of the goalposts for this. And Jeff Blair is our star kicker.
Well, Phil B also gets big credit for doing the initial 7670 code. So that got me kickstarted on this.
Yeah.
On the shoulders of giant dragons.
Giant
Giant dragons.
Thanks so much, Jeff.
All right, you're welcome. Good night.
Hey, thanks. Have a great weekend.
Brent, you just launched a beta of something.
Yeah.
Yeah.
What is secretly around now?
We've been secretly working on, but not really secretly,
We
a
post on
new.
our blog and we show videos.
It's kind of not very secret.
It's not very secret, but it's kind of secret. We've been working on a new service for Adafruit.io called WipperSnapper, and now it's in beta, which is really exciting. Which means if you have one of these 3 boards, or a Metro ESP32S2 that I'm going to work on support for tomorrow, you can actually participate in the beta by DMing me on Discord, and you need an Adafruit.io account.
Okay.
So, like, what this is it's a no-code interface for Adafruit.io. So, like, the Funhouse has a light sensor, and I have it plugged in over here. And if I click light sensor and click create component, it immediately sends the value every 30 seconds to Adafruit.io, which is really neat.
That was it. That was done.
That was it. Like, the component is
using-
dynamically configured.
Oh,
Like,
turn it over so that the value goes to 0.
Yeah.
turn it over.
Turn the board over.
Oh, the board
Yeah.
over.
Okay, so in like 30 seconds, it'll.
6672 right now.
Okay.
It's below the screen, right? Oh, I think I put my finger over it.
Okay.
And
Whatever it takes.
I bridged something. Hold on.
All right. Live demo.
Oh, it's offline. That's a good demo. You
Yeah.
want to show how when it disconnects, it goes offline.
Yeah,
Nice
so
work.
it goes
Real
offline
time.
and
Oh,
then
now
it
it's back online.
reconnects.
Yeah.
And it should
a
send
good
a
demo.
new value.
These are all things that we like worked on. Like, what if you accidentally disconnect it? What if
Yeah.
the sensor?
All right. Now it's off.
Okay, so we have to wait 30 seconds for it to update, right?
We should.
Okay, so you
Now it's 4467.
Yeah, so yeah,
you
now
made
it
it
updated.
brighter.
Yeah. I've somehow made it brighter by flipping it over and also bridged the contact by accident.
Okay,
All right,
so
so that's how fast it is. That's
Yeah, it's really quick to configure components, and then when you disconnect and reconnect, all the components reconfigure on your board as well. So like the state that you're seeing on this website is the state of the board at any time.
all right, so how, if people watch this and like that, I want to get involved in this beta, how can they ask politely to get included in the beta?
So you would message me on Discord, Brent.RU, and you would just say, hey, I want to participate
Not
in the beta.
privately, in the Adafruit IO channel.
Oh, right. Sorry. In the Help with Adafruit IO channel.
Yes, that's right. Don't DM Brent.
I'm okay with it, but we could post in that channel as well. And
Post in the channel.
at me.
At Brent, or you can post in the forums.
Yep. There's actually a WipperSnapper sub-forum on the Adafruit Technical Support Forum.
And do you need to have an IO Plus account, or can you use a free account?
Nope. You can use a free account or an IO Plus account. There are some limitations with the free account because it's a slower data rate. There are less components you can make, but you can use either with Adafruit WipperSnapper.
That sounds interesting. All right, so people should go to the Adafruit forums, go to the WipperSnapper forum, and post a message right now. Again, you have to have an Adafruit account anyway, so you might as well make an Adafruit account. Post there, and then with your username, and then if you're very polite, Brent will invite you.
Only if you're polite.
Pretty please, with sugar on top.
okay. We'll have some videos. We'll have some more examples of this, but we're kind of building this out in the open. We've been talking about this for a bit, and this is our soft launch for some folks that are in the community and more. Thanks so much, Brent, and hug report out to
You said by the
Justin
end of
and
it,
Lauren.
by the end of June.
Yeah,
Yeah, by the end of June, and we're at the end of June.
The end of June.
you got right on time. You had a few hours left.
You actually had a really good, you gauged the time well, which is actually quite impressive. You're like, well, I think we'll be able to launch the beta at the end of June.
Yeah, I figured it's about that time, and then we'll have some other announcements this summer.
Yep.
Okay, good
All
work.
right. Thank you so much, Brent.
Yay,
All right,
Ripper.
Liz, play us out.
Whoa, Liz is a white square. What's going on?
It's going to be kind of a weird demo. So I'm starting to work on a Bluetooth mouse that you control with gestures. So I'm using the Feather Sense, and I'm going to switch. This is just a blank PowerPoint slide with the mouse as a laser. So this is using my laptop mouse. So I'm going to plug in the Sense. And now I'm making the laser go across the screen with the Sense.
That's kind of fun.
Yeah, so I just got like a quick demo going this afternoon. So like I need to fine tune it and stuff. I'm thinking about using the gyro to affect the speed.
How fast you're twisting it means it can actually go a little farther.
Yeah.
That's kind of interesting.
Yeah. So just starting with this, but it should be pretty.
And how do you click the mouse button?
So I don't have that yet. I'm just doing the kind of moving around. But I'll probably have like some buttons, and it's gonna kind of be it's gonna kind of be a remote for a Raspberry Pi I'm using to run like Netflix and stuff. So it'll probably have some other controls as well.
Okay, how about for the mouse button when you put your finger over the light sensor? Because that way you wouldn't even have to wire any other hardware. It'd be good for accessibility because then you wouldn't need anything. You could just use it as is.
Yeah, that's really cool. Yeah, I will work on that.
Check out there's a light sensor, proximity sensor built in. So you try that.
Right. Okay, we'll do.
There might also be a button on the blue. I don't remember if there's an extra button. Maybe a user button.
Yeah, there is. There's a user switch. That's right.
Okay, great. You could try that too.
Cool. We'll do.
Wow, amazing. All right. Dots everywhere. All right, next up. Oh, JP. Wild JP has arrived.
Thank you, Liz.
Hey.
What's going on?
All right. Is this working? Can you hear me?
Yeah.
Hey, great. Okay. I had my computer restart right in the middle of waiting to get on. So I'm glad it's all working again. It was a quick rebuild of a bunch of stuff. So just a couple things I wanted to show. Speaking of inputs, and in one case, weird inputs. So first one, not so weird, but this is my beautiful new Adafruit MacroPad that I have just started playing around with coding on. And if you check out my little Atom session over here on the right, I'm just using it as a keypad. I just have 0 through 9, A and B, assigned to some of these keys with a little bit of blinking lights going on. I started playing around with some ideas of doing sort of a cheat sheet for what your different keys mean on the display here. And then I also have a little brightness with my encoder push there, the button in the rotary encoder, as well as reading some values there and displaying them as I play around with that that knob there. So that one is exciting. Lots of fun projects in mind with that. And then the other one was actually, I'm going to unplug this and show you. This is our little new Trinky QT2040. And the thing I love about this is that it plugs right into USB port on your computer, so you don't need a cable, and you can plug other Stemma QT types of sensors on top. I chose to plug in my Nintendo WiiChuck accessory add-on that we have, and now this is a fully USB compatible mouse that I can plug right in by adding just that little dongle basically to the end of the existing product there. So with that plugged in, if I swap over to Photoshop real quick, you'll see I'm able to use this as a mouse cursor just with the thumbstick, and I can hold the mouse button down just using the little Z button that's built right into our nunchuck.
It's gonna be good for like emulators, you know what I mean? Like have it work with a Wii emulator.
For sure, yeah, definitely. And you could also read accelerometer, which I'm not doing. You can read the C button. So there's a lot you can do with it, and you can use different tools. So if you switch around with keyboard shortcuts what tools you're using, you can now go and use like the paint bucket fill or whatever you want to do. So kind of an interesting way to really quickly and inexpensively make a fully custom add-on for pretty much any of these accessories. They all speak I2C. We have a library for using the WiiChuck and guitar and drums and turntables and all these different Wii accessories that are dirt cheap. You can buy them new, you can buy them used. You may have some in your garage or in your basement, and then plug them right into our little Trinky QT2040 there, which I'm super excited about. It's a neat little package.
Yeah,
So
the point of having that QT2040 was Phil and I kept coming in with Trinkies, and I was like, I actually am not going to be able to make every Trinky, so let's make a God Trinky, you know, like
this is the Uber Trinky.
And then the Super Trinky, and then you can plug any QT breakout that we have. And because like this is a good example, it's like it would have been cool to make a Wii to USB adapter, but like you can just do this and then bolt it on and you're done.
And then you get all the programmability in the world that you want, because sometimes these things exist out in the world as like a purpose-built thing that says, okay, you're dying to play Guitar Hero on this device, and so here's the dongle. But ours is really straightforward for coding it to, you know, I have it actually running in two different acceleration modes. If I push a little bit or I push a little harder, it goes faster or slower, and you can just fine tune it for your needs in the CircuitPython code, which is available as soon as you plug it in. It shows up as a drive. I actually did another demo. Maybe you guys are going to show it from yesterday, which is using the U2IF, which I'm really excited about because that turns the Trinky into essentially a USB bridge between Python on your computer and whatever the heck device you want to plug in over Stemma QT onto it. So it really opens up a whole ton of possibilities for you there.
Yeah, I've always wanted to have it like a unified system where it's like we have one driver and the driver is the same everywhere, and it's like we're finally getting to it.
Yeah, no, it's very cool. And we've had some devices that are just that bridge, but I kind of love the Trinky for the fact that it's both. It's a straight up RP2040 QT Py type of device, but then it's also able to be used as this bridge in U2IF mode. So super exciting product.
Thanks so much, JP. We'll be playing some of your videos tonight, and then don't forget, everybody, Thursday, JP's workshop. You can learn all about this.
Come on by. We'll be doing some cool stuff. Yeah, macro-paddy kinds of stuff, I think. So, all right. See y'all.
All right.
Okay,
thanks, everybody.
That's our show. Before we go, all the shows are the same next week. It's going to be a holiday on Monday. But I put in the chat, if you're going to get an AdaBox or you want to get an AdaBox or you're worried about part shortages, and wouldn't it be great to like pre-order something that might be really cool? This is kind of the way to do that. So AdaBox.com, we have less than 200 slots open. We have thousands that are going out. So now is the time. If you want to support Adafruit and all the shows, this is a good way to do it too. Adabox.com. It'll be shipping next couple weeks. And with that, thanks for making this the best half an hour of our lives every single week. The longest running and biggest show and tell online in the world. Adafruit Show and Tell. We'll see everybody next week.
Thanks, everybody.